Hi, this is Jordi Guimera from ANFOS 21, and I'm doing this presentation on behalf of our company and the Balear Water Agency in Spain. And we will see what has been happening after 10 years of aquifer storage and recovery in a carbonate aquifer, which was recharged by a deep well injection. My colleagues will be introduced right now: Esther Villanova, Roger Mas, and Salvador Jordana from ANFOS, and Biel Serra is part of the Water Balear Agency. The contents of the presentation is we'll be doing first a little bit of context because there are not many presentations of this area of the world here. Then we will see what is the motivation of the project and what we have done to establish a diagnosis of the problems that this well field has been experiencing in the last years. And then we will finish with some conclusions and recommendations. Okay, here we are. The Mallorca island is located in the Western Mediterranean Sea, and it is the Western Mediterranean is bounded by Spain, France, Italy, Algeria, part of Libya, and Morocco, essentially. The island is essentially a big, huge block of carbonate. It is composed of limestones of different ages that we will not be into the details here, but essentially is carbonate rocks. The sources of water of the island is just groundwater. There are no permanent surface water flows, and the demand of water experiences a huge seasonal trend because tourism is the major source of incomes of the island. So during summertime, there is a strong demand. So in winter times, this demand decreases. What are the sources of water in an island like this for a project of aquifer storage and recovery? Well, in the northern part of the island, there is a huge range that it is almost 1,000 or more than 1,000 meters above sea level. It is composed of carbonate rocks, of course, and there's a huge discharge that originally was to the sea in a particular part of this range. And this spring has been conducted to different cities and towns in the island in order to cover the water demand, and it is fully used during summertime. But there is an excess of water during the rest of the year, and this excess of water is precisely what is being used for water injection in our well field. Okay, the average water flow is on the order of 2,000 to 4,000 cubic meters per hour in the spring, while the average annual is injected water is about 3 to 4 million cubic meters, and this has even risen to an accumulated volume for during 10 years of about 40 millions of cubic meters in this particular well field. The aquifer storage and recovery well field of Sestremera consists of 4 platforms where there are 2 to 3 wells per platform. One is always for injection, and there might be 1 to 2 for pumping. And in total, there are 10 wells in a 200 meters row. The platforms consist internally in something like this, where the wells are drilled here, either for injection or for pumping in this case. When water is injected by gravity into these well fields, and it is conducted through an intermediate tank to overcome the mountain range. Okay, while the water is conducted to the well fields, it is successively injected through the wells, depending on the flow and the capacity of each of the wells, to compensate the available flow rate. If we see the geological profile, it is quite, so to say, homogeneous in composition. It's carbonate rocks, then it's carbonate sandstone, a little bit of carbonate rocks. There is a carbonate sandstone that we will see later on what is the origin and what is that may be one of the origin of the problems that here. So, but I anticipating things. So let's see that the drilling of the wells is about 750 millimeters and telescopic to the bottom, and they are cased with a screen of 500 millimeters straight. The depth of all of them is 200 meters, while the screen is 100 from the very bottom to the middle part. And the pumping wells, the pump is located at about 150 meters, and the water level depth is 60 meters in more or less all of them. It may be up to 30 when during the injection period in winter the groundwater level rises. So what happened is that after 9 years of operation, the most used well decided not to work anymore. That means that it reduced the capacity by 50%, and it turns that it was producing from an average 600 cubic meters per hour to 300 cubic meters per hour. And when they started to pick the pump to see what was happening, then it turned out that the pump was stuck. And after an inspection with TV camera, it was observed that there was a huge clogging in the bottom of the well. And not only clogging, that it took place from 50 to 5 meters of well loss in all of the wells, produced the fine sediment accumulated in the bottom. But also there was a lot of calcite precipitation in the slots and defective welding in many of the casing. So the objective of this project was to say whether we can elucidate what is the origin of the clogging of the well and the loss of the well capacity, to assess whether the injection system created any impact of the wells, and to provide some solutions on the short and the long term. So first we started to watch the hydrochemistry. And by studying the hydrochemistry, we see that, of course, all of the waters are bicarbonate type, but none of them are just equally bicarbonated type. We see that the spring source water is much more diluted than the groundwater at the well field, even though it is true that more or less they all behave similarly or belong to what we could say similar facies or similar family of composition. Okay, but it is important to see that they are not exactly equal. The original salinity, we believe that it is related to the presence of sea water in the recharge water, not in the aquifers, because there is no saline intrusion to this part of the island. In others, it is huge, but not here. And we see that the electrical conductivity of the water when it is recharging, it decreases. And why is that? Because the excess of water of the spring, it is much more diluted than the water of that is regularly discharging, because after the heavy rainfall period, when there is this huge excess of water available for recharge, then we observe that the electrical conductivity decreases. So then what we set up a geochemical model, and you may wonder why. I mean, what for? All water are quite the same. But we want to explore whether the precipitation and dissolution of calcite could indicate whether the injection of water is responsible for aquifer dissolution or any other process that may be relevant to the well field. Then we want to quantify these effects and to assess what is this impact in the wells. So the geochemical model consists of some processes, mixture and reaction that are displayed here, where the rainwater plus the carbonates may give rise both to the spring water, which is the source of the water to be injected, the groundwater and the well field. And the mixture of these two plus the interaction with carbonates also gives rise to the groundwater and the well field when this has happened, has experienced a recharge period. These are the sources these are the sources of water for the mixing terms. We have, for instance, in well one, we have the water, the aquifer. We have the mixture after some time after injection. We have the mixture after some more time of injection, and so on. And the spring water, which is the source, has also shows also some conspicuous differences in composition. The important thing to look is that the saturation of index of the water, which is always negative, indicating that this water can dissolve more calcium carbonate during the interaction with the calcite, with the aquifer. Okay, so we set up the different scenarios of mixing and reaction, saying that, for instance, with the injection, water injection number 2 and water injection number 3 with calcite, what happened? Then we mix these injection waters with different percentages of aquifer water and calcite, and what is the resulting mixture that we obtain. And what we obtain is that in the different scenarios, and after 10 years after the simulation of 10 years injection, we obtain that the volume of rock dissolved is some of a few hundred cubic meters, from 250 up to almost 500. And one would contend that this is a good news, because we are creating more room for storing water. So the aquifer is becoming more and more permeable. But in fact, if we consider that there are percentage of non-soluble particles in this aquifer, and these particles may be released from the matrix, they accumulate both in the aquifer or and the wells. So if they accumulate preferentially into the wells, they could produce the observed bottom clogging. So it's not such a good news. Also, we have studied the turbidity analysis. So the question is whether the suspended particles could produce a water well capacity loss, and certainly no. Well, it could be in a very, very, very long term, but we observed that the dissolution mobilizes almost 100 times higher volumes of suspended particles, and certainly of higher diameters. So this turbidity would not be relevant for this. In conclusions, we see that the lack of adequate maintenance resulted in the well loss capacity, and almost, for some of them, almost the loss of the whole well. Small changes in pH and disequilibrium between the injected carbonate water and the local water induces carbonate dissolution, and which we believe is the main reason for the well losses and clogging, because then some particles are released and these they accumulate in the well. We have not fully assessed the friction losses as a reason for losing the capacity of the well, even though they may play an important role because gravitational injection overcomes more than 60 meters in sometimes. And we have suggested to equilibrate the injection water through a carbonate filter bed in order to compensate and to obtain a higher pH, which do not dissolve the aquifer. And also, we have suggested to change the injection of the system with a bottom up, with a downhole valve or with a packer system in order to reduce the water velocity in the wells. And finally, we also suggested to employ another type of well screens in new wells. If new wells are going to be constructed, well screens mover type, because they reduce the friction losses. And if you are further interested in this type of effects, you can see the presentation of my colleague Salvador Jordana also later on in this congress. And that's it. Thank you very much. And now I am open to any questions that you may have. You have here my email, just in case you want to reach me in later on after the Congress. Thank you.